Hi everyone. Today we're going to study hazard function of reliability. Another quantity that we are interested in is the rate of failure of units. This is estimated by the so-called hazard function, denoted by h of t. Hazard function is also called instantaneous failure rate function. It indicates the proneness to failure or risk of a unit after time t has elapsed. However, it is not a probability, meaning it can take values greater than 1. Now this is the formula. H of t is equal to small f of t over capital R of t, where this f of t is the probability density function, while R of t is the reliability function. So we have our first formula here. There is a second formula that we're going to use when R of t is the only given in the problem. So the formula will be h of t is equal to the negative of derivative of R of t all over capital R of t. Let us discuss the bathtub curve. We have an x and y axis. Our x-axis corresponds to time, and the y-axis corresponds to the failure rate, or the h of t. This is the bathtub curve. This is divided into 3 parts. The first part here is what we call infant mortality. The second part, or the middle part, is what we call the normal life. And the last part is what we call wear out period. It should be noted that in reality, an item's hazard function or instantaneous failure rate is unlikely to remain constant throughout the majority of its lifetime. Most items age gradually throughout their entire life, then suddenly starting to deteriorate towards the end, as implied by the bathtub curve. Let us have this cumulative hazard function. The cumulative hazard function is defined from the hazard function as capital H of t is equal to the definite integral from 0 to t of the function h of t, this is small h of t, dt. This cumulative hazard function is associated with the reliability function as the R of t is equal to exponential of negative capital H of t, or the capital H of t is equal to the negative ln of capital R of t. Let us see this example. The failure distribution function, or capital F of t, of a building system is given by capital F of t equals 1 minus e raised to negative t over 100, where t is in years. Determine the hazard function h of t. Our formula for h of t is equal to the negative of r prime of t over r of t. So for step 1, let us compute for capital R of t. Given the f of t here, we have the simple formula r of t is equal to 1 minus capital F of t. This value of capital F of t is given here. let us substitute this value in the formula. So it will be like this. Then let us simplify the right side. Let us remove the grouping symbol and change the sign of all the terms inside the grouping symbol. So it will be 1 minus 1 becomes 0, and this negative here becomes positive. Therefore, the r of t is equal to positive e raised to negative t over 100. Step 2, let us compute for derivative of r. So it will be like this. R prime of t is equal to this exponential e raised to negative t over 100 times the derivative of this negative t over 100, and that is negative 1 over 100. Simplifying this, we have this negative 1 over 100 times e raised to negative t over 100. Let's proceed with step 3. Let us substitute the corresponding values to our formula h of t. The numerator is the value from step 2 and the denominator is the value from step 1. So it will be like this. H of t is equal to the negative of the quantity negative 1 over 100. E raised to negative t over 100 all over e raised to negative t over 100. This negative and negative becomes positive, so we can rewrite our formula into like this. Simplifying further, we can see that this e raised to negative t over 100 is common in the denominator and numerator, so we can cancel the expressions. So the final answer for h of t is 1 over 100. Note that we can say that the system has a constant failure rate because there is no variable in the answer. I hope you learned something from this video. See you again next time.